Hi, this is Antminer Repair, and today we are going to learn all about, or as much as I know about, the Antminer test fixture. And what you're looking at now is actually the login page to the test fixture. I've hooked it up to the network and started it up on a board, and we're going to go exploring in there. So if you like this type of content and like this subject, you could really help me out by subscribing. And the reason I say that is if I could get enough subscriptions from YouTube, they'll pay me, and it helps cover my costs for solder and doing all the video equipment and all of that stuff. So if you guys could subscribe, that would really help me. And also the watch time, just watching would be great because they clock me by the hour. And then for those of you guys who are just getting into this and want to learn or are repairing Antminer boards, we have a great Discord channel. It's up to 300 people, active community repairing and helping people repair boards or learn how to repair boards. The link of that will be in this video up top. So with that, let's get started. So today we're going to just log into the test fixture. My serial connection on the USB drive, when you buy these from Zeus or has really bad wiring. And so you pretty well need to redo the wiring, and somehow my serial device on the USB thing that they give you doesn't work. So I've ordered another one, but I really needed to test this board and find out what's going on. So I figured out how to get inside the test fixture and how to hook the program and save the output and do all that. So I'm going to show you how to do all that today. And then we're going to actually go through the output. I have two types of output. One is the first output, and I thought it told me to do something, and I did it, and I ran it again, and it didn't change a thing. So I almost have more questions than answers in this video, but I have a lot of answers, just things for you guys to think about if you need to get in here. So the password to get in the test fixture is just like the Bitmain Antminer. In fact, this is the software for the Antminer. So if I log in here, it looks like, this is the control board or something for an L3 Plus. I'm actually running on a T17 board, and this is running T17. So I wonder if the L3 Plus board maybe runs everything, which is kind of interesting. I never noticed that. But anyway, you'll notice there's nothing running. It does have a kernel log, and all it says is this stuff. So again, this is the test fixture, not a miner. So the first step into kind of getting into the miner is this. You have to go actually set the password. For some reason, setting the password in administration and redoing it. So I'm going to type in root here and then not use autofill. I'm going to type in root here and root here. And we're going to go look at the file structure of the test system. Maybe you guys have looked at the TF card. I don't know, but it's mounted on here too. I'm going to save this. And then what I'm going to do is I'm going to switch screens. I'm going to go to a terminal. Just a second. I'd have to restart that. Just a second. Switching something new here. New window. I don't think we'll do green. We'll do basic. I have no idea. Okay, that's just white and black. I'm just setting up a command shell. It's actually a Linux shell or a Unix shell. So let me go share that. Oh, one thing to notice before we go, do you see the IP address? I found the IP address of the test fixture just like you would find the IP address of a miner on there. And I noticed that this IP address popped up, and that's how I knew to go to that miner to get the login. So just like your miners, if you're looking at the status, the test fixture will do the same thing. Go find it, log in, and change your password. So just a second, I'm switching windows here. I guess it won't let me just switch windows. I have to stop and restart, so it's kind of a drag. But okay, so this is a Unix shell or a Linux shell. Sorry, I'm old. I used to work on all sorts of Unix systems. So that IP address, so what I can do now, since I've changed the login, I can actually secure shell in. So it's SSH -L, which is the user root. Wait a minute. Whoa. Stop. It's 192.168.1. And that address was 42. So I have to tell the IP address where it is. Then I tell it the user. It might not matter. You could have done it this other way too. But if I do this, the system's going to say, hey, it's an insecure system. Do you want to log in? It's probably built into Mac OS, which is what I'm using. I'm going to say yes, and I'm going to provide it a password, then I'm in. You'll notice the prompt will change. This is my Mac. So I'm going to hit return. It's going to warn me. I'm going to say yes here. Do you want to continue connecting? Yes. And then it's going to prompt me for the password. And I'm going to type in root because I set that there. And then I'm in the Antminer now. I'm in there. So all this is an embedded Linux system, if you didn't know that. And the embedded Linux system runs the Antminer. It runs on that Z-Link chip off your board. It's an ARM processor. So a couple things to note. I'm going to be changing directories. PWD means present working directory. CD means change directories. Okay. So I'm going to go up to the top of the tree and do an ls, and it'll tell you what's up here. So this is a very top root folder. This is like your C: drive for those of you guys who don't know Linux. It's not much different than Windows now because Windows copied Unix a long time ago for the directory structures. So just a couple places we're going to work. On Linux, when it starts up, it goes into this etc folder, into a folder called init.d. And that's where all the startup scripts are. And so what they've done is hook the test fixture into the startup. So we're going to go look at that script. Also, when it mounts the RAM disk, it puts it under /mnt. We're going to go look in there. And then finally, to get the output to a file to get it to display on the web browser, we're going to do a real quick web page thing, which is real easy. We're going to go into here and find the kernel log display. I kind of reuse that. Now, if you do this to your Antminer and go in to change this, the second you turn it off, it flushes it all down the toilet. You have to do it again. So I'm getting kind of good at doing this because my serial card's in the mail. So I'm kind of desperate. I had to figure this out and do this. So, all right. So there's another command in Unix called PS, which is the process status, as I think it's called. And it lists everything running. And there's a ton of stuff. It's a full-blown Linux operating system. But one thing that is running when it booted up is this guy right here. Okay. So that is actually what is running. I don't know what the daemon up there, the AVAHI daemon is. I don't think it has to do with the test, drop bear or something else. So that is the testing program they wrote to test these things. And if you look on your TF card without going through this way, you'll see single board test on there and a config file. And we're going to go look at those too, the config file, because I'll show you how to configure your tester just to look for ASICs and not try to hash, because it does various things. But one thing to notice is it's under MNT card. So this is actually where they stuck the TF card. They mounted it to MNT card. Let's go have a look over there first. So let's go look on the card. So I'm going to go to MNT/card. And then if I do an LS, which is a file listing, if you notice, this is actually for T17. Yours might look a little different. I have a file there called BB because I saved it. You won't have that, but you'll see these files. You'll see a pattern file. You'll see config. You'll see, so this guy right here is the RAM disk, which is what I'm traversing right now. It gets uncompressed and mounted as a disk for the Unix, and it has all the utilities. It's on the fly. I think this is probably the Linux kernel, but I'm not sure. It's probably what runs to do this. It looks like they test the LCD, and it looks like they throw in a couple kernel patches. So they have the LCD driver, so it'll display on that LCD. And then it looks like they have the field programmable array memory driver, which is probably the Antminer, right? And then they have a device tree, which is all the devices you can talk out. Oh, and here's another kernel driver, Bitmain. So maybe this is the actual talking to the board driver. They have a script called change parameter. I don't think you need to use that. So anyway, I want to show out a couple things, but there's single board tests, and that's what's running now. And the problem is it's running now, so how do you get it to run in a different way? And just another note, when Linux starts up, it writes all this stuff to a device called console, which is a serial device. It's from the old Unix days. You used to have a terminal sitting on top of the computer, and when bad login attempts would happen, it would print error message from the operating system to the console. So you'd sit there and leave a terminal there, and you could go scroll through all the stuff that got written to the console to see if you're having problems with your computer system. Back then, it wasn't a PC. It might have been a big system. So this is from way back then. This is why they have a console. And so Bitmain's test system uses the console, I've determined. And I could be wrong, but I'm pretty sure it's the console. And it just opens up the console and writes to it. So I have to preempt it as a standard output. I guess because it's running in single user mode, it prints to the console. And when I say single user mode, this could support many logins all at the same time, but it doesn't. They just have it hooked to run in for one user when it starts up. All right. So we'll get back to that because somehow we have to take the console output or wherever it's writing and stick it somewhere because I'm not using the serial device to capture my output here. But let's have a look at the config file. I think it's interesting. So I'm using an old Unix editor called VI. You can use, you can probably open it up in Notepad. It's just a text file. So this does a lot of stuff, and your config files might be a little bit different because this is for T17. And what's kind of interesting is this 1397 is what gets written to the EEPROM for a good device. So it probably opens up the EEPROM and checks to make sure it's the device. I have 30 chips. Not sure what that is. There's going to be a lot. I don't know what is. So there's all sorts of stuff they set. Those are comments. When they have a hash mark there, it's just comments. So not sure. And then they have all these core delays, pattern numbers. This is kind of interesting. It's not invalid when there's 30. It's invalid when there's not 30. So the way the programmer wrote this was not very readable. I think how the programmer, I'm not sure. I don't like how they worded this. I would have programmed it different, but that's okay. So anyway, there's all sorts of stuff. This is part of this is documented in the Bitmain manual. So this is its communication rate. Baud rate is 3, so it's doing 6 megabit evidently. I don't know what IO strength is. Here's the one thing you should be able to change in your config. All the rest I might not. But if you only want it to find ASICs and stop and not do the pattern test, which gets your board hot and will burn up a chip if you don't have a heat sink on, you would set this guy to 1 right here. Only find ASIC to 1, and it would just run the ASIC search test, which is probably in the majority of times how you're using your, you're struggling with, you dropped a chip and you're trying to see if you repaired the chip and see if it finds 30. If it finds 30, you're all happy. And what I'm trying to do is push the fold. I've got a card that runs 30, but it doesn't run very good. It's like, well, why doesn't it run very good? Maybe the tester will tell me why it doesn't run good. And that's what we're going to go into in a little bit later here. Might be a little bit long video, and it's going to travel in a lot of different places. But all right, so that's where you would test it, set it in the config file to, you'd set that to 1 to set your tester to only find ASICs. All sorts of frequencies here. Not sure. Level 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm trying to figure out this thing called level 1 versus level 4, but I don't think that's it. And so they just have all the parameters for the T17. They have it set up here. So it's, we use a temp sensor, temp 451. So it says that. Here's the chip numbers of where the temp sensors are, 7, 9, 24. So I guess it tells it where, and starting sensors 9, which is kind of interesting. I don't know what that means. So it gives us some parameters for temperatures, and then I'm not sure about the core nums. I'm still learning about that. Hardware versions. This is interesting. It's set not to overwrite the EEPROM, but I think it does. But they say you don't want it to erase all the memory. I'm sure you'd probably be in for a PIC refresh and an EEPROM refresh if you set this. I have not tried this, don't want to spend my time working on that quite yet. So I'm not that adventurous yet. So then it has some rules. some limits and some rules, and check the sensor types 5 times during the test. So anyway, you've got this config file. It comes in on your TF card. The TF card gets mounted on the Unix, the embedded Unix system running, and it's all here. So all the data from your TF card, when you plug it into the miner, comes here. That's not to say that the first TF card you put in your test fixture, that actually flashes the probably the PIC on the board saying you're going to run a T17 test. They call that the conversion card. So when you set up your tester, you do a conversion, and then you stick in a TF card the model you're using. I'm sure I would have to reconvert it if I chose another model. All right, so I started exploring there. That's kind of interesting because I was messing with the TF card. You can do weird things like look at all the error messages in these are just Unix. So I'm going to dump all the ASCII strings out of uimage, or actually, let's do it out of test. Sometimes you can cheat by looking at what the programmer did and what the programmer is looking at by dumping all the error message strings out of the executable. So an executable file is something you can't open in a notepad, but I can find the strings in there using the strings utility that Linux/Unix tells me, and then I can pipe it to page the output. So let's just take a look at some of the stuff that single board test has in it. So a lot of it's kind of some junk stuff, but then if you just keep scrolling through here, somewhere down here, usually I say strings -5 or something. Here's some stuff. So here's some of the error messages that they can print out. So if you want to run that command, you can just reverse the video, find that, and you can start looking at some of the stuff that they're kind of holding in there. There's a lot of stuff in there, see? So I'm not going to go through all this. It's just kind of interesting. I guess you could call it reverse engineering. I'm just looking at what they're doing. I'm not changing anything. I literally, with a hex program, could go change the error messages in there if I wanted to, but I don't want to. All right. So now back to the problem at hand. How does this run? So what happens when you turn on the system, it reads from the TF card, finds these 2 things. This mounts this as a whole file system. This runs the stuff as a whole file system. And then when it starts up the Unix, it goes to this folder called etc. etc has a lot of operating system utilities and setup, like the network and all that stuff. However, but I know just from my old experience that in a folder called init.d is where they keep all the startup scripts. So they have all the startup scripts here, and the .shells get run. It's a little more complicated to that because you can have multi-user versus single user, but this is the base folder where these shells run, and if you modify a shell here, it'll take care of it everywhere. And if you notice right here, there's a cgminer.sh. So in the etc folder init.d directory, there's a cgminer.shell. So let's go look at that. I'm going to look at it with a text file. The .shell.sh is a text file. It's just shell script. And so you do a lot of stuff. You set the path name so it can find programs. And then see, there's a Z-Link 7000 miner, see? LTC miner. So they're using the scripts off the L3. So you L3 guys really ought to like this. So I don't know what this stuff is. It looks like a red and a green light. This is how you get the red and the green, maybe. I'm not sure. But where I was looking for was finding where they run single board. So they do a lot of setup here, get hardware addresses. They might parse the config file a little bit here, but if you just keep going, this is some of the output that you might see right here. Here's where it runs. It actually runs, and it runs in the background. So they call it and it returns, and then it says echo single board test start. So it'll actually print this in your web output if it's running right off the X shell or the putty term that you use. But this is where the test starts. So everything else is probably run before this on the Linux system. And then it gets to here and it runs the test. And then what it does is it starts up the card and then you know there's a wait. You start it up and turn the power on, it waits, it mounts the Linux, does all this stuff. And then it displays that weird signal of, you know, hey, I'm here, and it displays something on the LCD and waits for you to press start. And so that's where this happens. This is the program. It comes off the TF card flash. So there's a different single board test for each board type, I would imagine. I'd sure like to get my hands on the software. I could really learn what it's really testing and probably do me better. It'd be nice to post to see if Bitmain would give away their testing software, but I don't think they will. It's just a stubbed version. So there's some other stuff in here. This is actually a shell script, so I can start, stop, and restart. And we're going to use this restart thing right here, right now, because right now this shell script and single board test is running right now. And I need to change the output of it, but it's already running and it's already decided its output. So I need to restart it with what I want to do. So the change you have to make in here to get it to a file, I'm going to just add this code and I'll explain what it does. At the end of this line, we're going to say append all output, which is 2 right arrows, to /temp, which is a temp directory. I think on Windows it's temp. You may not be able to see it anymore because Microsoft doesn't think you're smart enough. And then you just put, you know, test.output. So that'll create, so as this thing writes stuff, instead of going to the console, it redirects the output and appends. It doesn't clobber the file each time it runs. It appends this output to a file in /temp/test.output. Okay? So we're creating this file with the outputs of our test instead of it running to the serial device that you have hooked up. That's what does that, okay? So now to save your file, however you want to save it, you can go $ZZ, I go :write, and that'll save this file. That'll save it, but $ZZ and VI will do that. VI is ancient text editor for you guys, but I'm very versant with it. So I'm gonna save this. Okay, so it saved it. Now, just for hoots, if I do a directory listing, I can do a directory listing on /temp. And right now all there is a picmac and a validate. But as soon as I restart this, it's going to create this file. Now, how do I restart it? Remember I started talking about this? So the way to run something right here is to go in the current directory, which is // run cgminer.shell and give it an argument of restart. And that's going to restart the test utility. And it's going to end up running this new command here. And then it's going to run it what you call in the foreground. So I would have to wait for it to finish. And what I'm going to do is I'm going to do a special command to put it in the background. So, or actually to make it run in the background, I can just do that. Okay. That'll say start this up and run in the background, give me my shell back right away. So I'm going to go ahead and hit return. And it's going to stop the other one. Then it's going to restart it. I should see one more message. Yeah, okay, so I have my shell back. I can still go around, but it's running. Our new version's running. Now, if I do a directory listing of /temp right now, you'll see now there's a test.output file. And if I want to look what's in there, it's called cat/temp/test.output. So cat, the file /temp/test.output. It won't have much in there. That actually has some stuff. So here's the startup address, and it basically dumps out the config file, what it's going to run on. This is the config file. So if you see only find ASIC is 0 still, this is the config file as it was read from the config.ini, but this is the program repeating the config file it had. So that's kind of cool. All right. So right now we have the CG miner. We have the CG miner running. The only problem is after it does the test, how do you get this file off? I'm not sure. There might be a way in Secure Shell to download this file. I haven't used Secure Shell that much. We used to use Telnet in the old days. I could probably find that. I might be able to do some sort of command in Secure Shell and just download this file. But what I do, what's easier is I'm going to go back up to the very top folder. Let me get a drink of water here. Kind of a long one. And you see this folder, www. Well, this test fixture is running a web server, and you access it through the website. So I'm going to go down into that folder, take a look around. Logs, pages, and var. So I looked in the logs and I said, well, maybe our output's there, but that's actually the web server log. So that's not where we want to go. We're going to go down into pages. And I looked at pages, and if you look at that kernel log, what I want to do is use the web page kernel log to dump out the test results. It's not doing it right now, but I'm going to make it do it. And what kernel log does is it turns around and calls a CGI bin script, actually. This is really old code. So I'm going to go into CGI bin. And if you look in here, there's a get kernel log. Let me highlight it for you. Okay. So we're going to add a command up there to dump it to the output on the web server. So if I go look at that file, I'm going to VI it, which is text editor, get kernel log.cgi. It really is quite easy. It runs a command called dmessage. Dmessage dumps the kernel, and then it runs cat var log messages and looking for anything CG miner wrote to it. This is the stock one that if you were running a regular miner, it would be printing out those messages. Problem is, none of our test output is here. It was being written to console. We redirected it to that /temp/test.out. So hopefully I remember test.out. So what I'm going to do is add a command up above here. I'm going to insert with an I, hit return down here, and we're going to go cat /temp/test.output. Now remember that cat command just is like, what's the DOS version? It was, I can't remember how you dumped out the file, text file's output to the screen, but that's what it does. So when the web page comes up next time when I have this, it's going to dump my testing output here. And then do its normal stuff too. So it's going to put some other garbage in there that I probably don't want. And in fact, I don't. I probably should just remove it. So I'm going to save this by either going $ZZ or writing it. Okay. So that's it. That's all you have to do. So now we're set up so that if you go, so we're done with that stuff. So now I'm going to stop sharing this and go back to the Antminer's web screen. Right in the middle of where we were changing passwords. Okay, so we were in here. If you go to kernel log, which is what we just programmed, remember that test.out had the config file output and stuff. If I hit this, here it is. It added that stuff. Then it added a bunch of garbage down here, okay? But basically what was in that test.out file was this setup and then what was in the config file. I haven't run the test on the board yet, okay? When I hit test, a bunch of other stuff is gonna go in there and then this stuff's gonna be on the bottom. Probably should have just taken this out because I'm gonna show you my finished output and then I'm gonna discuss some other things on the finished output. So anyway, that's how, if you don't have a serial device, you can get your testing output. And I've learned how to do it fairly quick. I just go in and do it. It doesn't take very long. After you do it a few times, just write it down on a piece of paper, what you have to do, go do it and get your test output. And while you're waiting for a new serial device to be sent to you. Okay? That's part one of the video. All right, part two is I'm actually going to show you some output. Have you ever gone through the output, or do you just look for ASICs and know that it works and leave it? I started going through the output, and I have a lot of questions, so I'd like to open that up for discussion. So I'm going to stop the share now, and we're going to switch gears. All right, hopefully I can choose the right one. I think it's, hopefully this is number 40. We'll find out. I don't know who I'm sharing. Nope, not sharing the right one yet. Hang on. Who are you? It doesn't tell me which, so. All right, so this is number 40. So I ran the test on a T17 board. And I just wanted to walk through this. You recognize this. This was the dump of the config log. Now other programs are writing in here, so it threw the date kind of right in the middle of everywhere, but this is actually per ASCII domain received nonce limit equals 75. So in a couple of places in this log, you're going to get multiple programs writing to it at the same time. but I wanted to go through kind of the output. So I didn't know the APW9 was 3,600 watts. Maybe that's just a print error. I don't know. But basically, this is where I hit test. Was right here, and I'm going to see if I can. Let me see if I can zoom in to make this better. Make it much easier to read. All right, so that might be easier to watch on video anyway. So this is where it starts the test, and it looks like it does some initial stuff. Okay, so it just does some checking stuff. It looks like it tests if it can read from the EEPROM, probably. It looks like it looks like it resets the PIC, but it doesn't write to the PIC. It just says start over. And then it does regular stuff. So then it tests the heartbeat. That is the PIC chip that's on the T17 board. So it's checking the heartbeat, making sure it's sending out signals. Then it's setting up some voltage to start the miner. And then it's looking at the config file and starting it up. So it's enabling stuff down here, just all the stuff. And so then it gets down to the first test, and it says check ASIC number. And it makes sure, it looks like it checks twice actually, to make sure that it has 30 chips. Now, if we would have had that config flag, only check ASIC number, it would have stopped here. But instead, we told it to go on and do the pattern test. And I'm not sure I understand all about the pattern test, but let's have a look at here. So it chose a frequency of 650. So your miners by default run at 720, then it pairs them down if the boards aren't as good. But so now it's checking, working up. It's checking to make sure it can get up to the frequency to run the test. And it's setting up to run the test. And then I think the first tests it does is really tests the sensor. So I guess some of this stuff has warmed up the boards, but it looks like it actually starts to hash some stuff. I'm not sure if it targets the temperature sensor area for that. I couldn't tell you. But it does some hashing. This gvalid nonce num is a hashing type of function, I think. It's going to check your voltage, and pretty soon, so it's checking the temp sensors right here, one right after another after it does some hashing. So you see my temperature is warmed up. I have a fan on this, but it's really hard to keep cool. Again, somebody threw the date in the middle here, but it's okay. So then it hashes some more and warms it up some more. You see I got pretty hot on that one because I have a hard time keeping it cool, but it's just for the test. And then it's done. So this takes about what? I think it runs 70 or 80 seconds, all of this stuff. And you see different stuff happening on your screen. But what I want to, so then it kind of winds down. So it does its temperature sensor test. And then it does something here. And this is, I'm looking at this output right here. And I'm trying to understand this. And I looked at this a while last night. And it looks like that as it's working, you expect a number out of the chips. And the chips number has to be at a certain level. And if it's not, it's defective at the frequency it's running, I think. And something to notice here. So it says every ASIC require nonce number 5376. And then it listed the numbers of errors. So I started looking, it's 3. So 3 up here, which is actually chip 4. 1, 2, 3, 4. It's 1 off. Only return a nonce of 1. It's like, well, that's not good because you're looking for all these high numbers like this. Chip number 4 wasn't very high. It didn't get near 5376. These got near 5376, and it looks like there's some fudge factor that if it's in a certain percentage, it's good. But 4 didn't hash very good. 3 didn't hash very good. Let's look at 5. 5 is low. I'm just following these numbers down here. 8 is pretty good, but 300 low. And then 21. 21 is kind of low. It's not in the 5300s, it's in the 5000s. So it identified some chips that didn't perform. 3 was really bad. It's like, what's going on there? I'm missing a whole chip there. And it's not airing it out, it's running. I find 30 chips, but it doesn't look good. At least this is how I'm interpreting. So this is actually chip 4. So then I think it tries domain test, and these domain tests, there's 40 of them. I'm not sure. I think they're taking pairs or triples and different combinations of chips. And then they're saying what the domain is for 10 domains. I think these are your power domains. And you'll notice where that chip 4 is, which is the second domain, it's really low. I'm missing basically a whole chip off there. So if you look at chip 3, it's got some. So the chips cover for each other in some domains. I'm just not sure the overlay, and I'd really like to see the program testing this so I can understand this more. So then it takes the output above and this output, and unfortunately there was a date stuck right in the middle of this, so it kind of skipped. It's not as nice, but on your output and your tester, you've seen these. And it identified ASIC 3 as not good. It also identified ASIC 5 as not good. 21, it actually said was okay, even though it said it was an error up here. So what's interesting here is I'm not sure this matters. I came to this testing and I wanted to get this output because of this table, thinking maybe I've got some weak chips, and if I've replaced those, I could get the board restored, clear back up to the very beginning. But let me tell you what happened. I went in and I replaced chip 3. We'll look at the output in a second. So what happens if you leave? So the test runs, and it prints this on the LCD. So my temperature was no good because I gotta get hot, but the sensors are okay. But the pattern's no good. So it ends out and stops. And it says write the error for out for level 1. This was a level 1 test. And so it writes it out and to the screen, or writes it out to the thing. So anyway, so that was the first pass. Now, if you let your tester just sit there after the first test, it'll start up again, like after 30 seconds, I think. If you wait 30 seconds, it'll start the whole test over, but differently. And I think what's different, one thing to notice is, see this rate? It was a 93% nonce rate. So it's not very high. You want to get 100% nonce, I guess, is perfect, okay? So evidently level 1, you have to get a higher rate. So now what they're gonna do, I think, and it doesn't say this, is muck with the frequency or voltage or something and try again. So we rerun the whole test again. Basically check for chips, do the frequency thing. But I think they do something different here. I'm not sure what. They do the temperature check again. It just looks like it's running the same test over, but it's not. So they're gonna check the voltage. They're gonna check the temperatures again. I probably did a better job on the fan that time. They're gonna start hashing. And then they're gonna do the same table out here. But look, the same exact board right after. They still say there's errors, but my error's not chip 3, it's error 5. And if you look at chip 3 this time, it actually hashed. You see that? So, yeah, so I'm kind of confused. What changed? I don't know. It's required the same number, but it changed. It started working. And so if you go down here and look, it looks a lot better. All these domains, there's not a weak one over here. There's not weak stuff over here. It looks like it requires 4,000. Everybody's meeting the standard. Then it dumps the table again and everything's good. It didn't fix anything, but I think it changed the parameters on how to run. It gives a little status. No good times, no domain, no good times. True. One ASIC little domain, no good times, 0. I'm not sure here, but it looks like everybody are wise here, which means that it was happy with all the combinations of chips. So this is all test level failed, but it didn't. So it states this, and it states this on the LCD, that this is a level 4 hashboard, okay? So I think you guys might have stickers on your hashboards that say L1, L2, L6. I think what that is a classification of how you run the board, like the frequency or something like that. Because check this out, at the end of the very test, ignore this magic bitmap. Remember, this was something else running in the log. But here they actually tell you what they're throwing in the EEPROM. The 1397, then they have 2 bytes for the fixture version, then they have a bunch of bytes for the board serial number, the PCB version, and the BOM version, which, what is that? The parts list version? What type of temperature sensor it has, what its product ID is. I don't know about the test fixture CRC, but that goes in EEPROM. And then hashboard classification header, which is the letter L, which is probably a hex value letter L. And then notice this, it's set number 4. So I find that kind of interesting. That's what gets stored in your EEPROM. So what I'm thinking is we use this code editor, which I did a video on that last time. Actually, I've done one since, but not published it. But we did that. I'm copying, the code editor is copying contents of EEPROM. I wonder if I'm copying, in some cases, when I reset this board, level 1 EEPROM and setting this to level 1, and it's trying to hash and it's bad. When I could set this to level 4 and the system would know how to deal with the card better, so it would hash. I don't know, because the Antminer, when it starts up, you know, it says voltage and it sits there for a while. I think it tests the boards to see what it has to do and sets frequencies different based on the board. So I don't know the answer to that. I might try patching this L4 in the EEPROM code at this location for that purpose. So, all right, so just going through this is just kind of interesting because you usually just kind of ignore it and see if you got your chip working. So what happened was so notice this is 40. Every time I start up the test thing, it bumps up an IP. So I didn't like that chip 3 output for level 1. So I said, I'm going to replace the board. Replace, not the board, but the chip. Let me make sure this is, who are you? Yeah, okay. This looks the same, but it's not. If you notice, this is 41. So this was the next run after I replaced chip 4. So I said, chip 3's got to be bad. I'm going to replace it. So lo and behold, I ran the test again. I captured it just the same way. Ran all the same. Look at my results. Chip 3 was still 1. And chip 3 is really chip 4 because it's 0 base. So it didn't change anything on this test at all to replace that chip. I thought the chip was bad. The solder looked poor. So I put a brand new chip on it, replaced it, all checked out. It was missing a capacitor. I replaced the capacitor. Everything looked good, but it didn't change my test at all. Everything else was identical. It clocked back in at the bottom here. It doesn't say it, but it stayed a level 4. So even though I put a new chip on it, it stayed a level 4. So I'm not sure why. Maybe you guys know why. Maybe you guys know of the source code for the test. Be interesting to have a new test driver written for these to actually do a better test. There's a sort of open source project for somebody. Maybe we can take Brain's source code and build a public domain tester on it for those of you software guys. So I just wanted to share this with you. So this board is an L4 board. It passes. It hashed. It says everything's okay at L4. I don't know what L4 is. Maybe you folks do. Interesting, at this L4 rate, I got a nonce rate of 97%, which seems to be the cutoff or near the cutoff. So I wanted to show you all this because I think it's interesting, provide some thought. You can comment on YouTube if you guys know the answers. Better off, I'm going to post this in Discord. It would be nice to start a conversation under the test fixture in Discord, because that way we can have some back and forth and questions and answers. YouTube comments are okay, but you can't have real discussions, add videos, add pictures, add documents to show. So come on over to Discord if you know something about this and share it. I'll post this in the videos, sharing my videos section, and we can post after that. So anyway, I hope you guys found this content great. Remember, join that Discord channel. The link will be on this video. And please subscribe. It doesn't mean I'm going to know anything about you. It doesn't mean I'm going to spam you. It just means you're a subscriber and I get more points for it. Okay. So I appreciate you doing that if you enjoy this content. If not, you've skipped through it and you don't want to subscribe anyway. So that's okay too. I respect that. Thank you guys very much. I'm going to stop sharing and shut off the video now.